thank you, and thank you all for coming this afternoon. I think every conference I speak to, I end up speaking in the last session of the day, but I keep getting invited back, so I'm not sure if that's a mixed message. So bear with me as I figure out this clicker. So my name is Campbell. I am the Smart Mobility Manager for the City of Tampa. And so you may not know what a Smart Mobility Manager does. It's an uncommon job title, so I'm going to tell you. So my responsibilities include our Smart Cities program, our traffic signal program from planning to design to construction to operation and maintenance, our traffic management center, our street lighting program, our intelligent transportation systems, some piece of our special event planning and event management, our micromobility program, and our right-of-way permitting program. So it's a fairly broad set of responsibilities. I have a team of about 50 engineers and technicians on my team that have various roles within that set of responsibilities. But I just want to bring a little bit of context to what I do, what the cybersecurity need is, to paint the picture of what we see as our threat within the transportation sector of our operational picture within the city, and just to give you some context. So that Smart Mobility Division is one of our five divisions within the Mobility Department, the others of which are listed there on the left of the screen. So when our current mayor came into office, she had a five-pronged strategic approach to how she wanted to do business in the city of Tampa. And two of those are really kind of where the nexus of transportation cybersecurity lands. She has a high level of focus on transportation, as well as on sustainability and resiliency. And from the perspective of our highest level of city government, transportation cybersecurity is a topic that lands pretty squarely in her priorities. So I wanted to go over a little bit of a brief history on transportation networks and technology. If you didn't know, the world's very first traffic signal was installed in 1868 in Parliament Square in London. It was powered by gas, and it had some mechanical semaphore-type arms. And of note, it was not networked, so no real cybersecurity threat there. You might note it was about 50 years later before any type of traffic signal was installed in the United States. 1914, in Cleveland, they sort of caught on that this might be a good idea to have something automatically controlling the movement of vehicles. Euclid Avenue and West 105th Street, it was the first electric traffic signal. So we are able to lay claim to sort of being the first to have an electric signal here in the U.S. Also noteworthy, still not networked. So we're 50 years down the line. So going quickly through from then to now, in the 1950s, we had computerized controllers that sort of gained popularity, that gained some steam in the industry. 1980s and 1990s, we moved toward closed-loop systems. You might interconnect a dozen traffic signals that respond to different inputs within that closed loop. 2000s, fiber networks were really expanding within the transportation industry. And then now everything has an Ethernet port. So I put this picture here on this slide to show we have all sorts of things that now end up getting connected to our transportation network. You can kind of see the strip of panels is actually a solar array that is connected to one of our traffic signals in downtown Tampa. And it's probably a little bit difficult to see, but right next to the signal pole, there's a white cabinet there. Inside that white cabinet is a solar control system that is connected back through our traffic signal cabinet to our traffic network. So what does that mean? What's the threat landscape for us within the transportation sector? I was thinking about some things that I had sort of seen happen within the news about a decade and a half ago, when we had a few things connected, not necessarily a huge risk, but you'd start to see things like people hacking into our dynamic message signs and putting seemingly innocuous, well, I don't, unless someone actually took the message serious that there were zombies ahead. There is some risk to that in that those signs are there generally to warn you of a construction zone. There's an actual physical threat to the road, to the road user, but it's not an enormously high risk type of threat. And people tended to just leave these unlocked sitting on the side of the road. So a hack could be literally as simple as someone walking up and saying, hey, there's a keyboard here, and doing what they do. Fast forward 5 years ago, so sort of still continuing on that timeline I started earlier, we start to see that municipal systems are a threat. These two examples are not by any means isolated, and they're not necessarily OT threats either. But it does highlight the fact that municipal systems, transportation-related systems, are becoming more and more an enticing target toward hackers. And then the thing that really hit closest to home for me was in 2021 in Oldsmar, basically across Tampa Bay from us. Their water system was hacked. Their OT layer was actually hacked. And it may be apocryphal, but what I understand happened within that attack was that it was literally, the intervention was someone sitting at a console and seeing the numbers change on their screen. And thankfully, there was no harm actually done in the field. But from what I understand, that hacker tried to increase by 2 orders of magnitude the chlorine going in the water or something like that. So it was a true threat to public safety. So I think about those things. I think about the increasing risk and the enticements for people to hack into a municipal system, and I look back at my suite of responsibilities, and you kind of see I've highlighted the things that, to me, raise alarm bells, the things that have some potential for vulnerabilities. So what does that mean? Trying to get into the mind of the potential hacker. What could they do? What kind of, we were talking about the Italian job sort of scenario that we do have some protections against. But even within the protections that have been built into our system for decades, there are certain things that, if you knew what you were doing, you could definitely wreak havoc on the flow of traffic and how people are interacting with our system. And something that really highlighted to me a potential outcome was a couple of years ago. This was in I think it was February of 2020. I think is the date on there. They could have waited a month and there wouldn't have been any traffic to mess with. But in February of 2020, CSX, which cuts all the way across the peninsula of South Tampa, they decided to do maintenance on just about all of their crossings at once. And it wasn't that there were no places to get across where that dividing line was, that cordon across the southern peninsula, but it was just enough that people had to go around 4 or 5 different crossings that were on major streets. And again, not directly related to a cyber hack, but should you see some sort of network-based attack or say, an increase in all-read time to the maximum that they could, think to implement, these sorts of unexpected events can be pretty devastating to the economy and to public safety. We do have a lot of major special events, and it's interesting to see how when we have a huge impact, like a week ago we had Gasparilla Festival, the parade in Tampa that you may or may not have heard of, draws about 500,000 people. Huge impact to traffic, but when we can plan for them, it's fairly simple and straightforward for us to manage. But when it's an unplanned, when no one knows what's going to happen, obviously that threat becomes that much greater. Oops. All right, so that's sort of the threat as I see it, and a little bit about the history of our system. We have a significant project that right now is implementing some improvements in our cybersecurity landscape, as in addition to a fairly significant network expansion and asset replacement within the field. It's called our ATMS project, which is an advanced traffic management system, if you're not familiar with it. So 6 years ago when I arrived at the city of Tampa, most of our downtown, all of our downtown, most of our signals were still on twisted pair copper. They were interconnected to a central system made by a company that went out of business about 20 years ago. So there's a saying, there's a phrase about being so far behind we think we're ahead, and that's kind of the spot that we found ourselves in, with the anticipation that this ATMS project was going to come and solve some of those problems. We did have a sector within our city near the airport and the football stadium that had already been upgraded, but the rest of the city is all being upgraded as of right now. So that project is a design-build project done in collaboration with FDOT. They're actually managing the project for us within the city of Tampa's transportation network. I don't know if I said, it's about a $40 million project. Key project components include, we've got 80 miles of new conduit, 125 new miles of new fiber, 63 CCTV cameras, which is about a 60% increase in what we've got. Traffic detection at 44 intersections, an upgraded detection system. An analytics software package, 15 roadway flood sensors, new servers and workstations, and replacing 355 signal controller cabinets. And so within the context of this project, we found that our key opportunity area was that signal cabinet replacement. If you don't know, probably about 90% of traffic signal controller cabinets in the United States are controlled by a single key. That you could go to an online auction house and buy for a few dollars. And as we continue to increase the number of nodes in our network out in the field, literally putting them in a box that is somewhat secured but in a sidewalk, as cybersecurity professionals or as IT professionals, whatever your role is, I think it's plain to see that is a threat that we need to mitigate. So the opportunity that we are taking advantage of within the context of this project is within those replaced cabinets, we are installing a network monitoring and intervention device made by Mission Secure that will stand in between the cabinet and the rest of the network. We for decades have had a device that actually stands in between the controller, the signal controller, or a PLC, if you will, and the components of the signal. So, the Italian job scenario is theoretically not possible. You can't have green for east-west traffic and green for north-south traffic at the same time. It would send it to flash. But the threat to the network that someone could just hop into the cabinet and plug into our network controller, or our network switch, and get in there and do some other things was that area that we found we were most uncomfortable with our exposure and that we are trying to address with this project. So with that, I know we're going to talk a little bit more about that probably within the question and answer session. I know Rick from Mission Secure is going to be up here on the panel with me. But I will turn it back over to Larry, and then we'll go from there.